Hi everyone, it's Mrs. Hanson here. I've been asked to work an ALEX problem, and I thought it would be easiest to just do a quick video instead of try to type out the answer. This comes from our ALEX homework in Module 4, Weak Acids and Weak Bases. We are given some data about weak acids, specifically nitrous and hydrofluoric, with their Ka value, and we're also given some information about Kb values for some weak bases, ammonia and pyridine. Using this data, we're to rank the following solutions in order of an increasing pH. In other words, the first number 1 choice would go next to the solution that will have the lowest pH, which means that it's most acidic. Number 2 next to the solution that would be less acidic, all the way up to number 4, who's the most basic. So thinking about the lowest pH to the highest pH, the strongest acid to the strongest base. Let's take a look at these salts. Notice that these are all salts. In other words, they are the product of an acid-base neutralization. Just to clarify, we know the pattern that says when an acid reacts with a base, they neutralize one another by forming a salt and water. Now, I like to write water, as you recall, as HOH, separating it into its 2 ions, equal part acid ion, equal part base ion. That way, when I look at the salt that is formed, I can predict the parent acid and the parent base that was neutralized to form that salt. For example, in the first row of that, we see ammonium bromide, NH4Br, ammonium bromide. That means that the parent acid that was used to form that salt was HBr, hydrobromic acid. And it means that the parent base that was used was ammonium hydroxide. NH4Br is the salt that forms from the acid-base neutralization. And of course, it forms a salt and water. Now, the reason we need to know the parent acid and the parent base is to predict how the salt will affect the pH once it forms. We know that the strong acids and the strong bases do not hydrolyze when they form their conjugate pair. HBr is a strong acid. It is one of the 7 that we had to memorize. That tells me that Br negative, which is its conjugate base, will not affect pH. However, this base, ammonium hydroxide, is a weak base. That tells us that its conjugate acid, ammonium, is going to hydrolyze, which just simply means reacts with water to form its conjugate pairs. NH4 plus will affect the pH because its parent base is weak. Now, how does it affect the pH? When ammonium hydrolyzes, which just says plus water, and form its conjugate pairs. This extra proton that ammonium is carrying is being donated back to the water molecule. We form conjugate pairs through the process of hydrolysis. And notice that when we formed hydronium, H3O+, this solution now is going to be acidic. It formed the acid ion. This tells me that this salt, once it's formed from this acid-base reaction of HBr, NH4OH, it's going to produce a solution where the salt undergoes hydrolysis to create an acidic solution. So right now I'm just going to tabulate NH4Br is going to be acidic. Here is our next salt, Ki, potassium iodide. It formed from the neutralization of an acid-base reaction. Think of water as HOH. The parent base was potassium hydroxide. The parent acid was hydrogen iodide. KOH is one of the strong bases we have to memorize. It's a first family metal. All first family metal hydroxides 100% dissociate. A strong base as a parent tells me that it will not undergo hydrolysis. So the K plus has no effect on pH. Since this HI is also a strong acid, just as HBr was above, that tells me that I negative will have no effect on pH. This salt, because it has a strong parent base and a strong parent acid, will not affect the pH of a solution, and therefore I know it's going to be neutral. The next salt is sodium fluoride. Sodium fluoride, NaF, has a parent base that is strong, so sodium does not affect the pH. Hydrogen fluoride, HF, is a weak acid. That weak acid will undergo hydrolysis and will affect the pH. Let's take a look at how it does so. When the fluoride ion undergoes hydrolysis, which just means reacts with water, the conjugate pairs form, and the conjugate base of that weak acid is going to turn the solution basic. Notice how the hydroxide ion formed. This solution I know is going to be basic. The last one we have is pyridine chloride. So pyridine chloride, C5H5NHCl. This is the positive ion. This is the negative ion of the salt that's formed. We know that the salt had a parent acid that was strong, so no effect on pH. This, however, has a conjugate base that is weak. And notice right up here, the pyridine is listed as a weak base, so we know that it's a weak base, which simply tells us that C5H5NH+, when it undergoes hydrolysis, is going to transfer a proton, this proton here, and give it back to the water, forming pyridine. And that tells us that the solution is going to be acidic. Here we know the solution is acidic because the first cation has a parent that is a weak base. So all of that really is review. It's an opportunity to just really highlight what hydrolysis of salts are all about. We now know that the first solution and the last solution are both acidic. We know that the neutral solution will have a pH of 7, and we know the most basic solution will be sodium fluoride. How can we tell the difference between these two? Number 1, ammonium bromide, and number 4, pyridine chloride. That's when we need the Kb values. Remember, they turned the solution acidic, so you technically need the Kas to compare. But remember, the stronger the base, the weaker its conjugate acid. Ammonia is the stronger base. How do I know that? Oh, because it's a tiny number, but yet it is still a larger number as compared to pyridine. The stronger base means that this is the weaker acid. Here, pyridine, this is the weaker base compared to ammonia. Therefore, it's the stronger acid. The stronger acid will have the lowest pH. Then I would rank ammonium bromide, who is also acidic, but not so much as the first one we talked about, pyridine chloride. The neutral solution would be ranked third, and the basic solution ranked last. I hope you found this tutorial helpful.